Hey guys, I'd like to start talking to you about graphs and solving absolute value functions. So let's go ahead and get started. Today's function that we're going to use is y equals the absolute value of x plus 5 minus 2. And the first thing I'd like to do is just start with the parent function of y equals absolute value of x. Now I know that we've graphed that a couple of times, and remember its vertex is at 0, 0. And anything that you plug into x will be changed into the absolute value of x and will be made positive. So right now we have all positive values of y. So let's take a look at what the vertex would be of this function on the left. And that vertex is very similar to vertex form for a parabola, and that is negative hk. So we know that the vertex for this new absolute value function should be at negative 5, negative 2. But how is that, right? And so one thing that I like to do almost for all of my graphs is I'd like to find the roots if there are any. And so I'm going to go ahead and let y equal 0. I'm going to plug in 0 to my function. And I'm going to go ahead and solve for x to see if there are any roots. There might be multiple ones. I don't know. Right, so we bring the 2 over to the other side. Then we throw off the absolute values. We set the equations equal to plus and minus 2. We continue to solve. And we see that x equals negative 3 and x equals negative 7. That tells me that there's going to be 2 roots. So this new absolute value function should cross the x-axis at negative 3 and at negative 7. Okay. Next, we're going to go ahead and find the y-intercepts. And we always do that by letting x equal 0. That's a really nice way to see where the function crosses the y-axis. So everywhere that we see an x in our function, we're going to plug in 0, and then we're going to solve for y. And the absolute value of 5 minus 2 is really just 5 minus 2, and that gives us 3. So this function is going to cross the y-axis at positive 3. So we know a couple of things. We know the 3 roots, we know the 2 roots, and we know the y-intercepts, the 2 x-intercepts and the y-intercepts. And then finally, we know the vertex of this function, and so we go ahead and we draw that absolute value function, and indeed it does look like an absolute value that was shifted left 5 and then down 2. So finally, the domain of this function is going to be all real x values, all real numbers for x, and then the range of the function will be all y values greater than or equal to negative 2. So the next thing we want to do is kind of ask ourselves, well, what would happen if we, for example, took this function and we put a negative right out front of this function? What would change about this graph, right? And so the first thing we start off with is, well, it looks like the vertex is going to be exactly the same as it was before, negative 5, negative 2. So nothing happened to the vertex, it's still hk. But we should assume some sort of flip to this absolute value function. So instead of what looks like a v, it'll look like an upside down v, right? So let's investigate. So step 1, I like to work from the inside out of a function. So inside of this function, very deep inside of this function, is x plus 5. And when I say the inside of the function, if I were to plug in a value to x, what would happen to it first, right? And you'd say, oh, well, you'd take that value and you'd add it to 5. So that's what I mean by working inside out. So the first step is the x plus 5. So that would mean that we would be using a translation and moving this function to the left 5 units. Okay. The second thing that we would do to this is we would look at the flip of this function, which is the negative sign on the outside of this function. So that makes this function flip down essentially, or across the x-axis. So let's go ahead and see. We have a left move and then a flip upside down on the x-axis. And then finally the third thing that happens is we're going to take this function and we're going to shift it down 2. So we're going to move 2 units down for the vertex. And so notice the vertex is still at negative 5, negative 2. And there's our new graph in purple. And Finally, let's verify all of this by solving for the roots and then the y-intercept like we just did previously. So again, when we solve for the roots, we're going to let y value equal 0. Okay, we'll plug in 0 where y is, and we'll start to solve, moving the 2 on the other side, multiplying both sides by -1. And now let's stop here and let's just take a look at what we have. We have -2 equals the absolute value of x plus 5. So I want you to stop and ask yourself, can I think of any number that I could plug in to x where if I took x plus 5 in absolute value, I would get the answer of -2? Okay, and I'm going to say there's no real number that you could think of that would actually do that for you. So no number exists where that would ever make that true. So essentially, there's no roots for this problem. This graph never crosses the x-axis, and that's what it means by there's no real roots. There's no solution to this because nothing would ever make this true. And we can see that graphically, that parabola doesn't cross the x-axis, and that's why there's no real roots there. And the next thing we're going to do is we're going to find the y-intercepts. And again, we do that by letting x equal 0. So we plug in 0 everywhere that we see an x, and we'll simplify. And we get y equals -7. And so yes, this will cross the y-axis at -7, even though it doesn't cross the x-axis anywhere. And so that would be the difference between those two absolute value functions. Finally, the domain is going to be x is all reals, and the range in this case is going to be y values less than or equal to -2. Thanks a lot. Have a great day.